Lab, Amgen, BIOVIA Allotrope Integration Project, looking under the hood. And so we have Gong and Ji in the presentation.
Great. All right, thank you, Jamie. This talk is actually a continuation of the presentation we had back in June at the GSK meeting. And I decided how to present the product we have put in our production system. So before we move into the because not all of this was in the last meeting, so Winnie and he asked me to break a little bit of the best part of the presentation. Some echo in the meeting. Okay, great. Thank you. Don't touch it. Right. So basically, 4 years ago, Dana and James sold us a dream, and they're trying to sell it to more people today. So actually, one dream is a little understatement. It was actually a trilogy, and if you can do this. So what they said, what James and Dana said is, what if you can have all your data at your fingertip, and you can very accurately, quickly find what you want to see from the ocean over the. So that's the data access. That's the first part of the trilogy. Second part, now you have access. What if you can quickly interpret the scientific meaning of the data you're trying to looking for? So for example, here, you can quickly navigate to the project you're working on, looking for a specific lot of the material. You want to see the stability result of that from the ocean of the third part, the final best part, the business intelligence. I want to see how much data, how efficient my staff are in my organization. Little competition between the different sites. How many people are cranking out more data and useful scientific information? So that was the dream that Dana and James presented and mocked up with actually Spotfire 3 years ago. And then when Austus was on board to Allotrope as the technical team development, the dream became more clear from a daydream to a dream at night. So 6 months after, this was put together by Wolfgang, and showing the first part, as you can see here, the AFO, as many of you probably used to the acronym now, Allotrope Frame Ontology. So that addressed one question I think someone asked this morning. When you have a lot of different terms, very similar, assay analysis, how do you drive consistency? This AFO is driving that consistency. Managing the taxonomy and then serve as a terminology service to all the upper layer applications. So everything, all the instruments, all the data spit out can be harmonized, converted into a consistent actual data format, and eventually be uploaded into data lake. So now all the data from all different instruments are in one place. So this is how got the Amgen project started. It was a very bold one. We scrapped everything. What did we scrap? We scrapped 5 different instances of electron notebook, 3 different instances of LIMS system, totally scrapped, starting from scratch, starting the journey with BIOVIA. Hold our breath, take and try to have one system we call a holistic lab. So it's one system that the entire process development organization within Amgen is using today, and covering the biologics development as well as the synthetic small molecule modality, drug product, drug substance, attribute science, all living in one environment. And we started the front end, many of you probably recognize, is electronic notebook. But what is actually behind the scene you don't see, it is one system, back end, connected to many different things. As you can see here, this is one experiment. On the top, the user don't leave the system, but instead, by scanning the barcode on your asset, you'll get the instrument metadata from a Maximal system. That's our asset management system. But the user don't need to access Maximal. All they're living in is their notebook. Nobody gets trained on Maximal. Everybody has training, right? Don't raise your hand. And the second part, middle part, is the material. Again, we have CISPRO as a material inventory. Nobody gets trained on CISPRO because they don't see it. But when you scan the barcode on your vial, It tells you, you go to the SysPro, grab back the information, what material that, which lot, who made it, etc., etc. Now, interesting part, samples. Finally, we have samples the analysts hold on very tight to. By tracing this, you'll see that naturally, instead of creating the sample from nowhere, you take the material lot and then create sample to it. Naturally, you trace the history of it. So now we can see that now, material to sample, you track that genealogy. So everything is linked together. Finally, we can put out the sample onto the instrument. The bottom right side is actually our instrument data. So now you can see, right, instrument accurately captured from maximum by scanning, no typing or transcription. Material directly scanned, pulled from your accurate material inventory system. And then you keep that genealogy from material to sample. You know which lot of material it came from. And then finally, the result actually knows who ran it, which instrument collected that, and also which sample, for what purpose, from which material lot. Now everything is connected. That is the holistic lab that we're trying to get in. So what enabled all this is to be clear, we don't have ADF in our production system yet. 3 years later, we're on the verge of doing that. But what's really interesting, Allotrope will help us, is the taxonomy, the consistent vocabulary that enabled all the data collection. So now we have all the data pushed into our data lake. Remember that graph, Wolfgang helped us picture. This is our live system of data lake. Remember the first stream? Have all your data in your fingertip. This data was outdated. This was June. At the bottom right corner, you probably can see vaguely, we have 300,000 result set in the data lake. Again, this was outdated. I just checked a minute ago before I sat down here. Right now, it's 537,000 data points between June and now September. And it feels like, when you walk into the casino, when the payout, that number keeps rolling. That's what this is. What happens is every 15 minutes, all the data from notebook automatically be pushed to the data lake. And now they're living in one place. And also, we actually can get our legacy data from notebook, from the LIMS system, all living there too. Because of the consistent terms from the allotrope, now I can easily pin them together. So that's the exciting part. The first stream, we have all the data at our fingertip. This is Spotfire. It's actually the dream that Dana and James throw at us. This is our front end to build that. My colleague Don, on the side, actually is the chief architect behind all this. Use a Hadoop, take all the file from instrument, from the notebook, and publish it there with consistent taxonomy, so we can consume it. The second dream, how do we, find quickly the scientific data we can interpret? So you can see, you can pick the project you care about and then search on that and find that this is the stability for biologics measurement. You're looking for the stability measurement of the aggregation of proteins. You can easily see now across the time course how the stability, the aggregation is changing. Again, all in the data lake. By applying the right selection and query and to the filters, you'll find your data very quickly. The third part, business intelligence. I wish there were some managers in this room seeing this. This is all the data that actually feed into that. We can see exactly how many experiments be created at each site. And you can definitely focus on any particular site or period of time and see that. This shows the growth of the number of users in our system. We started deploying in 2015 of July. Small group, now we have actually over 1,200 users in June. Now we're over 1,300 now. So everything, all the information now is all available on the web, actually in the cloud, because Don Intelligent Design, our data lake is in the web, Amazon Web Service. So from anywhere we go, we can go on there, except on the GSK campus. This is a separate story. If you were at the June. So this really, again, bring back, the thing here. We were sold a dream, and that started with Spotfire, and then 3 years later, actually with the help of Allotrope Taxonomy, by working with the BIOVIA on this audacious kind of journey, we're now able to actually realize at least part of the dream, have all the data in one place, and can easily find that. So that was a quick recap what happened in June. What I'm hoping Jane can, will be interested to see, open the hood and see how the magic had happened. Thank you.
All right, thanks, Scott. Okay. All right, can you guys hear me? Yep. It's good? All right, so how does it all work? Gong showed you the pretty picture of the notebook with all of the connectivity and showing all the wonderful magic and creating all that great data. Underneath the hood, and Lenny never fails. So Lenny, yesterday or 2 days ago, Lenny was talking about his duster and whatever. And so last night I was in the hotel. I'm like, okay, clearly I'm going under the hood of Lenny's duster. And I painted it for him, yeah. So for anybody who was here the other day, you'll know what I'm talking about. The rest of you guys just think I'm crazy, and that's fine. Yeah, this is a souped up version of Lenny's. We've seen all the different Allotrope slides. I particularly like this one because it shows the framework and then it shows the enabled software working together, generating and creating all of this wonderful value over here. When you think about the framework plugged into what we provide at BIOVIA, we're providing one lab connected into the framework from Allotrope. And what does that mean? If we start to look at the detail of it, when we're thinking about one lab, we're thinking about managing all of the materials and equipment and people in your lab. We're talking about executing and managing all of your recipes and procedures, managing your experiments, reports, and the planning of all of that work, requesting work and doing work and so forth. If we start to think about that, that's underlying all of that. There are vocabularies and units, there are measurements, there are unit operations, there are materials, procedures, and experiments. The other day we were talking and somebody said, it's hard for me to see the value of connecting a piece of equipment and collecting some data out of it and just seeing that one thing. If I just do that, do I really get business value? And you can get business value out of that. There's no doubt. What we're talking about giving the tremendous amount of value with Amgen is the holistic view from top to bottom across the whole continuum, providing all of that in a connected, holistic way. And that is enabled by the ontology that is defined by Allotrope for equipment, materials, processes, and results. And so if we start to look at that, it's really important that we need to be able to take this computer science thing of ontology and we need to be able to connect it into one lab. The last thing in the world I want to do is sit in front of a terminal and type in all these vocabularies and ontologies. We need to be able to synchronize that in an automated way. And so there's a video here that will show us how that all happens. You can look at an ontology and it's this, whole string of all these different, a file with all these different data points in it. We can go into that file using Pipeline Pilot, using protocols that we've written, and we can read those ontologies. And as we're reading those ontologies, we're turning them from text out of the ontology file, and we're turning it into computer data storage in the form of a triple data store, and we're bringing that all into our system magically, and we have all this, now we just have a whole bunch of data in our system, which is still not very intelligible, but we can now translate that into, magically at the end, translate that into a set of vocabularies in our system to define, in this example, results in the system. Now, all we've really done is taken a file, processed it, pulled it into one lab. We still don't really have a lot of value yet. What we now need to be able to do is put some things on top of that. And so if I take that and I now look at it in the system, we have vocabularies to define all the equipment. We have the vocabularies to define all of the readings and so forth. And again, what does that mean in the grand scheme of things from a lab standpoint? Not really anything yet. But if you think about equipment, we've grouped equipment into classes and types, and the actual instances of equipment. So you can take a gas chromatograph and you can connect it to an equipment class. You could take an Agilent 6890 and you can connect it to an equipment type. And you could take a particular model and or instance, and you can connect it to an instance of that type. So now we've got the inventory of your equipment, and the inventory of your equipment maps an ontology. So we're getting closer, we're getting some value now. Now, if we can take the data from these pieces of equipment, we can parse that data, we can map it to parameters, which are synced with an ontology and vocabularies. Now, I can go and collect data, pull it out of the file, and I can say that data is related to that particular ontology. And then when I store it, that data is associated with an ontology, and other data from other equipment of that class type is stored with that, referring to that same ontology. Now I can start to look at all the data that I'm collecting from all those pieces of equipment in a standard way in my lake. And then you can start to get some pretty cool value out of that. Now, the equipment vendor is responsible for providing the equipment types, and Allotrope is working on and providing value with the Allotrope data format. Now today in the system, truth be told, at Amgen, we are not parsing from Allotrope ADF. We're parsing from the native format from the equipment. Now we have that ability in our system with Pipeline Pilot. We can open up, and we can write parsers, and we can pull all that data out, but it's hard. I mean, I don't want to say it's too hard. We can do it. It's not like the 72 Duster. It's better than that, but it's just, it takes work and it takes time, right? What we really want is we want these parsers to be configured in a way that are easier. And I'm going to show you how we're actually making tremendous progress on that. And then, of course, we have the ontologies, which map the different reading types. And, of course, we have the software, which is going to be storing and interacting with that, the scientific software. And, of course, that's the BIOVIA software. Doesn't have to be BIOVIA, though, by the way. We want it to be BIOVIA, but it can be, we can be interacting with other other software vendors as well. This whole thing doesn't all have to come from BIOVIA. All right, so then what do we get from that? Now we've got the equipment taxonomies, we've got the equipment's all classified. Now we have a whole inventory of equipment, and now we can collect data from our equipment, right? So we're back to where we were the other day. Somebody said, we can collect data from equipment. How much value does that provide? You can see it provides some value, but now we can take all of that equipment and we can standardize the way we collect data and standardize the way we store the data, so we can talk to directly connected instruments, which might be RS-232. We can talk to these file-based instruments, and we can talk to the web service-based instruments. And again, truth be told, really we're doing these right now at Amgen, not this one. We're working on that one though, and that's one of the things you saw with Tetra Science the other day, because they're going to actually be able to provide us an ADF file for the GE ACTA, and the GE ACTA we'll basically talk to Tetra Science. They'll give us an ADF file. We'll be able to pull that right into the system. So again, we can work together as partners in the network, in this network as well. It doesn't have to all come from BIOVIA. So take all that equipment stuff and marry it with the S88 process model, where I have a process, a stage, an operation, an action, and a parameter. And I can now map those process ontologies to my methods. So we have a tool called Compose. Compose lets us take a library of operations which can be synced with your ontology. You can drag and drop from this library and build out a method. Now with that method, you now have the ability to say, well, it's not a process, it's loss on drying. I'm going to pre-weigh, that's my stage. I'm going to weigh my sample, that's my unit operation. I'm going to weigh, that's my individual step, which I'm going to take a tare. That's connected to the weight, which is the reading or the parameter from the equipment, which from the Metler, which is the balance class. And now I have the magic happening. I'm in the lab with my tablet. I'm running through my loss on drying. I press a button, and I collect a weight. Not only can I collect a weight, but I can collect the pH, and I can collect the HPLC readings, I can collect the GC readings, all of those things. And what does that look like in the lab? Well, I'm going to show you a little video. This is a very short video, but in the lab, I have my request to run a loss on drying. I click on it on my tablet. I press the button over here to collect a weight. I click on my balance. It tells me it's out of calibration. So right off the bat, I know it's out of calibration. I can't use it. So I'm going to pick a different balance. I collect. It tells me it's calibrated. and I collect the data, it's 85 grams, and I put it into my method. Now, all that magic happens because of all the underlying capability. I can connect to the instruments, I have my process ontology, I have all of that, and I have effectively automated my procedure for doing loss on drive. Now, that's a very simple example, but it just keeps building on the same thing. The cool thing is that I have all that data stored in a standard way that can be mined, connected to ontologies, and this provides tremendous value. Now, the story goes on. I just don't have enough time. Gong took all my time. Sorry, Gong, I'm just kidding. You didn't really take my time. We obviously need to connect the material data model into this, and we need to be thinking about samples as a role for a material, and we need to, bring that into the picture, right? And you can imagine how that would happen. And if you want to see that, we can show you that someday. So if I go back to the big picture, I have my equipment. On my tablet, I'm saying collect some data. I pull it into a server. I take that data, hopefully is coming in an ADF format. I'm applying my measures, taxonomy to that data. I'm putting in that data into my Hadoop lake or in any lake or any regulated repository in an ADF format. And then I can mine that data, pull it into my ELN. And ultimately, that's what gives us the capability at Amgen that Gong started with, which is this whole big picture in a very connected way, all right? So I'm moving kind of fast, but I want to show you one more thing. This is the parsing from an ADF. So what we've done is we've created an ADF reader and an ADF writer. It comes with our software out of the box. You can now have the ability to read ADF files, and there's all sorts of settings in here. This is the underlying IT stuff. The scientists would never see that, but this is the stuff that kind of makes it happen under the hood, right? And so this will show you how we're actually just writing an ADF with a bunch of data. We're then reading that ADF, and there's a bunch of different parameters in here. And for all the Don Rolfs in the room, we can go and look at this on the side, and you guys would be happy to see all the bits and bytes and stuff like that. But it turns out to tear that data apart into all of its package information, into all of its data, and all the different things that are in the ADF, and then it actually creates an XY chart of the XY data. And this is just one example of that. Of course, Pipeline Pilot can do all sorts of really cool things to visualize this data. This just happens to be a very simplistic view of the spectra. The last thing I want to mention is, in addition to all of that, you might be thinking, how do I make this all work across the globe? I want to run this holistically, and I want to make this work not only in my research lab or my development lab, but I also want it to work in manufacturing. So we've been working really hard with help from Amgen and others to try to create a distributed data acquisition environment where we can have all of the equipment connected in Boston and all of the equipment connected in San Diego. And potentially even, so these are development sites, this is a manufacturing site. We're going to pull all that data into the cloud and then be able to bring it into one lab with a one lab client or potentially even an EBR client where they're both accessing the same cloud environment and pulling data out. There's a lot of really cool advantages of doing that. Again, trying to move fast, so I'm just going to kind of end it there. And the last thing I want to say is thank you to Merck for having us. Thank you very much to Amgen for being so patient and so informative and sometimes choking us and whatever, but it's all good. And for Allotrope for providing, this overall forum and Ostis and so forth, and for BIOVIA for letting us go down this path. So I don't know if I have any time for questions, but if I do, I'd be happy to answer them.